This keynote is gonna, answer the question of whether or not computation could empower fairness in Web3 and AI ecosystems. Everything from, computation, unlocking blockchain and AI for real world, digital interactions. All of that and more will be discussed in this next keynote. So come over here to the conference area and listen to the founder of MOI Network. So please give a warm welcome on stage to Anantha Krishnan.
Good afternoon, or should I say late good morning. So I'm Anantha Krishnan, founder of MOI Networks, and I hope you all like the monkey out there. It's very happy, isn't it? I'm not sure if all of us are happy in our digital world today. A lot of stress, a lot of privacy anxiety, a lot of security concerns. So over the next 10-15 minutes, I'm going to try to attempt to tell you how we make digital fair and make digitally interacting society happy. So the way we use technology has changed, and we no longer just connect by technology. We live, operate, and of course, transfer information we still Google. I think some of us still do. But the fundamental use of technology has changed. We live through technology. But have you looked at whether the computation has fundamentally changed? I think we are still working on a computational framework which was developed 80 years before, probably earlier than that. So the question that I have is, do we really need to take a look at the fundamental tenets of computation while the use of technology has changed? So let's take an example. John and Myra, two people in New York City, on a fine Monday morning, get up and look at the weather. Sunny day, bright day, 60 degrees. John wants to go to Upper East Side to register a house, and on the way he stops at a very famous barista where they serve specialized coffees, but he wants a very quick coffee. He goes there, orders his latte very quickly, and then pays very quickly through his credit card and runs away to his registration Upper East Side. Myra, a coffee connoisseur, who's an economist, she also comes to the same coffee shops. She talks to the barista, she verifies the sources of the coffee, where the beans come from, orders a specialized coffee, and then sits there and really enjoys her coffee and takes the time. And John now goes next to his Upper East Side registration, and now he spends 2 hours, talk to his lawyer. Lawyer says that it'll take a week for his registration. He has to pay $5,000 for the registration. And he spends his time. Now what does this show? Real world interactions, where digital is supposed to drive us, is not one size fits all. It's the fundamental difference. Real world interactions are one size fits all. The same coffee shop, Myra and John had different interactions. John wanted speed and efficiency. Myra wanted an experience. But that's not all. When John went to a different situation, different interaction, the same person, he wanted trust and experience. He wanted a completely different experience. So do today's computational model support that kind of a personalized computational framework on the same code for each and every one of us. Can your large language model today support different people differently based on what their personal preferences are? That's the foundational question. Real world is not one size fits all. So to understand this, not all digital activity is the same. Looking up for weather, when John and Myra looked at the weather, is just information. Paying for coffee, buying a house, that's value. So there's a fundamental difference between how value needs to be managed and information needs to be managed. Value exchange is about participants and their preferences, whereas information is about general purpose utility. Everybody agrees the weather in New York was 60 degrees. So a code can support that, but can it really support the kind of experiences the real world is looking for? So what we call as digital interactions, not digital programs, that we are moving on to, all real world exchanges. Real world exchanges centers around participant and context, not necessarily data and logic. So to support real world exchanges, you need true context, and that context is not about the weather in New York City. It's your personalized context. And what is the context? It needs trust and intelligence. So any real world experience needs a context, and the context is really around trust and intelligence. Without that, you won't be able to build real world interactions in the digital world. How does today's computing model support that? So without going into the details of what today's computing model is, for people who are really interested, it's based on this concept called a Turing machine, an universal computing model. They are fundamentally built around data and logic. What I mean by that is the model only looks at three parameters today. The computing model today fundamentally has three parameters. Where is the information processed? What information is getting processed? How the information is getting processed? Brilliant for managing information. But all of us know real world exchange is not about where, what, where or how. What is the missing element? Can anybody say?
Who processes?
Who processes. So the point is, the who element is fundamentally missing in the computational model, which was built about 80 years back, and that was built for an age of predictability, automation as a tool. So it doesn't have the who element at all. So your computation does not understand who you are. You are an attribute of the computation. You can't make the logic work for you. You are an attribute inside logic. So that's why your large language model today cannot be different for different people, because the fundamental computation paradigm is around automation, not around personalization. So what we have built is, our hypothesis is what we call as contextual compute. It's a fundamentally new computational model which computes over participants and context. So what it means is you enter, for example, for blockchain programmers today, assume you're programming Ethereum, what is the first thing you call? A smart contract. So a smart contract, a participant, then you are an element inside the smart contract, so you're controlled by the requirements, parameters of a smart contract. But what if you had to start with the participant and the computer says starts with the participant and brought the logic after that? So the whole thing changes. So the logic would adapt to what you want to do. So this is the fundamental idea of contextual compute. It's a new base layer for the Internet of Value. So we keep saying Internet of Value, but then the industry keeps processing information, not value. Values are about participants and context. And in this, who is the first element of computation? And we have built three layers on that. At the base layer, we have something called context chains, which provides the trust that John wants in his real estate transaction. In the middle layer, we have something called participant-centric compute. So for example, your large language models, your AI machines, all of them work under the context of a participant. And finally, your smart interactions. So people talk about agent-to-agent interactions, but then it's not enough if only agents talk to each other, is it? They also talk to human beings, and human beings also have to talk to other systems. So the interactions have to be smart. It's not enough, the world is not going to be just agent to agent. I think we all are going to be alive still, aren't we? So we need to be able to have smart interactions which are not agent to agent. It has to be agent to agent, plus agent to people and agent to system. So it's a smart interaction layer on the top. So which kind of allows you to get the kind of personalization you're looking for, what Myra was looking for in our coffee transaction. So why contextual compute really matters? So it's a very important point. Today's universal compute, what they call as the universal computing machine, just infers intelligence or infers trust and intelligence through code. It's an inference process. Whereas what we are saying is contextual compute for real world, it emerges trust and intelligence through an interaction. So for example, if when John went to the real estate transaction, the trust and intelligence kind of adapted to what he wanted. So it emerges intelligence. And lack of context is what is the fundamental problem for AI and blockchain today. So let me take a couple of minutes to talk about that. AI today is not safe because it's not participant-centric. And blockchain today doesn't scale because of the global ordering problem. So if myself and another person was doing a transaction exchange today, or value exchange, at the same time, John and Myra will not be able to do the transaction exchange because they're all congested on the same block because they got ordered in the same way, because that's how the network operates. But real world, they are independent events. If you're a participant-centric model, your ordering or your blocks will be created at a participant level so you can achieve true parallelism and concurrency. Similarly, if your LLM models were on participants were on top of the LLM models, the models will allow you to kind of customize for each user that you're looking for. So this is not just an idea. We have built something called a MOI protocol. It's the world's first context-aware protocol built on contextual compute. And it primarily is able to drive 4 use cases. Real-world assets, people talking about tokenizing real-world assets. One of the largest problem in real-world asset tokenization is safety. So today all your assets in smart contracts live inside the smart contract. So if one smart contract gets hacked because it's programmatic, the assets are not safe. In this model, it starts with the participant, so only your assets come in. So safety is a huge benefit using this model. The second is decentralized AGI. So people talk about decentralized AI that needs massively parallel computation, which means you can't have centralized bottlenecks. So that's again solved because of participant centricity. 2 agents are interacting, 2 other agents can interact at the same time in parallel. So it supports decentralized AGI. Decentralized public infrastructure networks, DeepIn. So we talk about today utilities where you can have local utilities which drive local capabilities without having centralized controls. But then such a model would work only if your network itself is distributed. So most of the blockchains or networks today have less number of nodes. They're not globally distributed like an internet. So with MOI, we are going towards a million node network, which is parallel and distributed like internet today. So it will support deep-in capabilities. Finally, peer-to-peer gaming. So one of the biggest problems for gamers is to move their assets from one game to another game. And the largest challenge there is you have to build these bridges between smart contracts because every game is a smart contract. In this model, your assets lives with the participant, so it's like a user moving from one game to another game, so interoperability is kind of very native. So those are very practical, large use cases that we can drive with this technology. So just to finish up, what are the real world interactions in MOI? How does it work? On today's change, buying a coffee and buying a house have the same user experience, processed the same way. but not on MOI. You'll get different experiences, different speeds and different costs, so you're very efficient. So how will an AI use case work with this new technology? An AI health assistant today, for example, in large language model or an AI machine, if it gives you health advice, it can't specifically look at your allergies, your compliance requirements, your situation. It's not possible. But in this model, it's possible because the participant is at a higher level than the logic. So you'll get personalized attention customized for you. How do we do this? I won't drain this slide. We have built the entire stack ground up. We have a new data structure, new ordering mechanism, new consensus, and new Sybil resistance. Even because one of the largest problems for centralization today is proof of work and proof of stake centralized. So most of the protocols are centralized. We have a human-centric Sybil resistance, which kinds of gives you the growing decentralization over a very large network. So if you think that we can change the internet in a fundamental way and humanize and put participant centricity so that it works like the real world, come join us. We have an event tomorrow evening at between 6 and 11. Please join us there. Visit us. We can talk one-on-one about this concept of humanizing and creating a technology which fundamentally works for the real world. Thank you.